So in this particular example, we're actually going to be graphing a quadratic from standard form. Now standard form is f of x equals ax squared plus bx plus c. And as you can see, our example, f of x equals negative 2x squared plus 4x plus 3, is in standard form. So when we use standard form, we have to follow a different procedure than we do when we have intercept form, which gives us the two x-intercepts, or vertex form, which provides us with the coordinates of the vertex. So the first thing I'm going to do is I'm going to identify from this equation my a, b, and c values. So a is negative 2, b is positive 4, right here, and c is positive 3. Now that I have these three values identified, I'm going to use them to actually put my quadratic on the graph and form my parabola. The first thing that we're going to use is the c term. When you have an equation for a quadratic in standard form, the c value is always representative of your y-intercept. So that means that this parabola is going to intersect the y-axis at 3. So I'm going to go to my graph, and I'm going to put my y-intercept at 3, and that would be the coordinates 0, 3, because your x value for anything on the y-axis will be 0. So I've already been able to determine what my y-intercept is simply from looking at my c value. The next thing we're going to do is we're going to identify the axis of symmetry. And the axis of symmetry is the vertical line that runs down the center of the parabola. It cuts the parabola into two equal halves. You look at it as if it were a line, and you folded across that line, the parabola would fold symmetrically on top of itself. So to find the axis of symmetry, I'm going to come over here, axis of symmetry. We have a formula or an expression that will enable us to find this axis of symmetry. And the formula for the axis of symmetry is x equals negative b, or the opposite of b, over 2a. This should be easy for us to calculate, seeing as we've already identified our a term and our b term from our equation. So I'm going to plug in those terms, and for b I have 4, and for a I have negative 2. So when I plug these in, I get negative 4 for my top value in the numerator, and 2 times negative 2 gives me negative 4 in the denominator. So those are my values. Negative 4 divided by negative 4 is, of course, 1. So what this means is that the axis of symmetry for my parabola is going to be a vertical line at x equals 1. So I'm now going to draw this axis of symmetry on the graph. And again, x equals 1. That is my axis of symmetry. So my parabola will be situated symmetrically around that line. Now, once I know the axis of symmetry, I do know that the vertex is on that line. Our vertex is always on the axis of symmetry. So the next thing I'm going to do is I'm going to use my results from the calculation of the axis of symmetry to find my vertex. So my vertex is actually going to have an x value of 1. So the question is, what is the y value of my vertex? In order for me to find that, since I know my x value, I'm going to go to my original equation, and I'm going to substitute a 1 in to the function. So f of 1 is going to equal negative 2 times 1 squared plus 4 times 1 plus 3. Again, I'm just plugging the 1, which is my x-coordinate for my vertex. I got it from the axis of symmetry, into the original equation to find the y value for my vertex. So this term comes out to negative 2 plus 4 plus 3. And when I add these all together, that gives me 5. Therefore, my vertex is at 1, 5. So now I can go on the graph, and I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. And I'm going to plot my vertex at 1, 5. So now I've got my vertex and I've got my y-intercept from my graph. The next thing is I've got to find some additional points so I can identify the shape of the graph. Now because my a term is negative, -2, I do know that my parabola is going to open downward because a negative a value means that my vertex is a maximum. It is the highest point and the parabola will be opening downward. Because I know this is the line of symmetry, I know I can plot a symmetrical point on this side, just like this one. But in order for me to get an accurate shape for my parabola, I need to add a couple of additional points. And instead of having to plug in to the original equation and solving the entire thing, we can actually use our a value. There's a shortcut for the a value. So using our a value, we're going to take f of x equals -2x squared. That's the only part of our equation we're going to look at and examine. We're going to use this to determine some points for our graph. So if we look back at our graph, we already have a point plotted over here, symmetrical to our y-intercept. So now I want to go 2 units away from my vertex. So I'm going to go 2 units away from my vertex. So what I'm going to do is I'm going to come down here and I'm going to substitute 2 in for x. And when I solve this, I get 2 squared, which is 4, times -2, which is -8. Now what this value tells me is that when I go 2 units away from my vertex, when I go 8 units down, that will give me another point on my graph. So I'm going to come up here to my vertex, I'm going to go 2 units over, and then I'm going to go 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to give me an additional point because I know this is symmetrical. I know that this point's going to have a buddy or a mirror image on this side. If we want to check this procedure and make sure it works, let's look at the y-intercept we already have. And let's look at the point that we plotted, that it's its mirror image over here. Let's come over and follow the same process. Instead of plugging in 2, this particular point and this particular point are actually 1 unit away from my vertex and from my axis of symmetry. So if I come down here and I plug in 1, I get 1 squared times 2, which is -2. And what that means is when I go 1 unit away from my axis of symmetry, to find my next point, I go 2 units down. So I'm going to go 1 unit over and 2 units down. And so you can see you can use the a term, the a value, to find other points on your graph without having to plug into the entire equation. So now we're ready to draw our parabola. So I'm going to start at my vertex, connect my points, start at my vertex, connect my points, and there is our parabola graphed from standard form.